Hello everybody. Today I'm going to be talking about the interaction of Civil 3D and InfoDrainage. Now the vision is that eventually we would prepare all of our data within Civil 3D. We would then bring it into InfoDrainage, perhaps fairly temporarily, to do the hydraulic analysis, and when that's complete, we would then go back to Civil 3D to integrate into a BIM environment or do whatever else it is that we want to do within Civil 3D. So how far are we along towards that vision of being able to do that complete round trip from Civil 3D into InfoDrainage and back out again? Now I'm using today the 2022 release of Civil 3D and the 2021.7 release of InfoDrainage. And it's useful to start by understanding what the basic building blocks are. So we're looking now at InfoDrainage, and there are really 5 different types of data. Firstly, there's the junctions or manholes that exist within most urban drainage catchments. Then there would be the pipes which connect up those provide the connections between those manholes. That's number 2. Then number 3, there is the inflow areas. So this at the moment is a manual process. Engineers would use their skill and judgment to derive the area which drains to each manhole. And what can help in this process is if we look at a background CAD drawing, we can see the urban environment that exists around each manhole. Now the crucial thing about this is that InfoDrainage and its predecessor MicroDrainage only considers runoff from impermeable areas. So whilst doing this assessment, we're really concentrating on the hard standing areas, the roads and the roofed areas which contribute to each manhole. And this, as I'll say at the start, we're looking mainly at a stormwater system today, although similar principles would apply to foul or sanitary systems. But a crucial aspect of this is how much of the rainfall landing on this catchment actually makes it to the manhole. And as I say, that's dictated very much by the impermeable area which exists within each catchment. And that's going to be a crucial factor later on, which I'll talk about in more detail. So we've got our inflow areas. That's the third, if you like, building block. And then what we've got is the stormwater controls. So these could be the ponds, the swales, the bioretentions, the permeable car parks, those sorts of storage structures. That's the 4th building block. And finally, number 5 is the associated inlets and outlets. So we're talking here about things like hydro brakes, orifices, pumps, weirs, any of those sort of aspects. So those are the sort of, if you like, the 5 main building blocks. And the summary is that when it comes to the first 2, the manholes and the pipes, we are a very long way along that road of being able to take everything to and from InfoDrainage and Civil 3D as we'd like. There's a few caveats there. I personally haven't looked in detail at things like odd-shaped pipes and unusual cases like that. But for basic manholes and circular pipes, even ones which don't have necessarily standard pipe sizes, we are a very long way along that route, and we can take data backwards and forwards very easily. When it comes to the third element, subcatchments, I'll show you the functionality that we have there. We've got a great deal of functionality, but there are still things that you need to do within InfoDrainage whilst you're doing that round trip process. When it comes to the 4th and 5th elements, the storage structures and the associated ancillary structures, as I say, such as the orifices and the weirs, then there is certainly more work to do here. It's not currently possible to create things within Civil 3D and subsequently import them into InfoDrainage. If you take a storage structure from InfoDrainage back into Civil 3D, it appears as a surface, so it does allow some visual representation of it, but it doesn't exist as a pond or bioretention or swale within Civil 3D. There's no equivalent object there. Similarly, with the structures, the weirs, the hydro brakes and the pumps, they appear as simple lines within Civil 3D. So again, it's not possible to prepare those objects within Civil 3D and subsequently bring them into InfoDrainage. But if you take them from InfoDrainage into Civil 3D, then it makes some simplistic representation of them. So that's where we are. We're very good on manholes and pipes, pretty good on catchments, and right at the beginning of the journey with the other structures and the ancillary associated structures. So let's look at how we prepare some data within Civil 3D with the intention of then exporting it and doing that round trip process within InfoDrainage. So moving to Civil 3D now. The starting point is the first thing that we want to do is to set up a metric template. So I'm going to set up a new metric template there. So we've got a new drawing associated here based on the metric template. Today that's the one I'm using. I'm not using any country pack or anything like that. It's just a straight metric template. The next thing is to set up an appropriate grid coordinate system, because we're going to be bringing in a variety of data, and it's obviously important to have it all at the same grid coordinates. This is one of the most common errors that we find if people start importing or exporting data from any package. If things don't line up, it is generally a problem with the coordinate system that's being used. So to set up that, we go into the settings, right click on the drawing, and edit the drawing settings. Come through to here. The category datums is the Great Britain. So just select that. Here we go. Great Britain. And then if we look at the grade available coordinate systems, the one that we're going to use today is this 1936 British National Grid. So that's the one that we need to set up. Now, a starting point for most InfoDrainage models is going to be some surface data. We need surface data, or don't need it, but it's useful for defining things like manhole cover levels, and when objects such as ponds flood onto a catchment surface, we need it for routing the flood water across the catchment surface. So it's used for a variety of different items. We can use it to set the level of a pond perimeter, for example. So it's used for a variety of different things, and a good ground model or some good surface data is really the cornerstone to a good model. So the first thing we're going to bring in is that surface data. So the way we do that is go to Insert. Now there's a variety of different formats that it could be bought in from. The one I'm going to be using today is this land XML. And then we just need to go and find the file that's been prepared in advance. It's just this road 1 file, so I'm going to open that up. Now we've got some options here about exactly how that data is going to appear. I'm told that we need to untick this source data and then press OK, and it should then go away and bring it in. So that's our surface data. Okay, what I'm going to do is I'm just going to edit it now. So if I go into the Prospector tab and then click on the surfaces and go into the properties, first thing I can do is change its name. So I'm just going to edit its name to match the source data, and then I can edit how it's shown basically, but don't need to anything else to be edited there. So we're going to set that up. Now the next thing is, as with a lot of Civil 3D work, we need to set up a catalogue. I can't claim to be an expert in either Civil 3D or particularly catalogues, but my basic understanding of it is that this is a very long list of potential attributes, and then as we create our data, and particularly as we export it and then re-import it, we need this catalogue to identify the items and give them references as we do that import and export process. So setting up a catalogue is the next task. So do that from the Home tab, and then under Create Design we want to set the pipe network catalogue. Okay, Okay, so I'm just using the Civil 3D 2022 default version, and then from that I can pick the metric catalog for the pipes, and same for the structures. So I'm just using the two metric catalogs there. Okay, so currently we've got a very long list of potential attributes that are being included here. So press OK on that. And those of you who are experts in Civil 3D will know this better than me, but once we've created a catalog, the next job is generally to create the parts list, which again my understanding is that it's a subset of the catalog and deals specifically with the items that we're going to be working with. So to do that, we go into the tool space and onto the settings tab, and then we find the pipe network within that, and then we go to the parts list. So we're going to right click and create a parts list from there. So once we've created our parts list, first thing we want to do is to give it a name. So I'm going to call this one InfoDrainage specific. And then when we go into the pipes tab, we want to add a parts family. So at this point it's reading from the catalog. So from this vast catalog, the only ones that we're really interested in today is going to be the concrete pipes. Okay, and then when we click and expand that, we can then right click on just the concrete pipes and add the part sizes. Now at this stage we're going to take all of the part sizes, both in terms of the wall thickness, but more particularly the inner pipe diameter, which is what InfoDrainage works with a lot. So we're going to add in all the available part sizes from that catalog. I'm going to do a similar thing with the structures. So if we go into the structures now and add a part family there. Now the one that's particularly relevant for InfoDrainage is going to be this one, the concentric cylindrical structures in SI units. So we're going to click on that, and again when we add the part sizes, we're going to ensure that we include all the available inner structure diameters. Okay. I'm going to be doing a separate video on how you deal with non-standard sizes, particularly for the pipes. We'll do a specific video on that, but at the moment we're using the default list from the catalog. Okay. And I'm told that parts lists are saved as part of the drawing, whereas catalogs aren't, but the parts list is no use unless it's associated with the correct catalog. So it's important that we set the catalog up first and then the parts list subset of that. Okay, so we are nearly ready to start creating our pipe network. So back into the Prospector tab. What we're going to be doing is I've got a pipe outline here, which is another drawing. So it's a very simply digitized set of lines within Civil 3D, has no attributes as such. I'm only using this so I create this this data set consistently. I know it works once I get it into InfoDrainage, so no other reason than that. I just wanted something to digitize and snap to rather than just sort of creating it freehand. So I'm going to copy this across. So I'm going to copy this clip across, paste it into my drawing. So just I need to paste it across, need to keep the origin, so paste it into there. So that's our very little pipe network, just one branch that I'm going to be digitizing today. So once I've got the outline of my pipes in here, the next thing I want to do is to create my pipe network. So from the Home tab, I go to Pipe Network and then the Pipe Network Creation Tools. Now in here I can give it a network name, so let's just call it Stormo1. I need to choose my InfoDrainage specific parts list that I created, pick the correct surface such that so I can pick off the manhole cover levels and that sort of thing. And I can also choose how the labels appear. So I'm going to choose something fairly simple. Structure label style is going to be none. For the pipes, it's just going to be the name of the pipe. It's not going to be any other attributes. So once I'm happy with that, click OK. Creates these. This is showing me how it's going to create these pipes. Now at this stage I'm really not that interested at all. It's not that important to set up the correct structure sizes and the correct pipe sizes. I just need any old sizes, because the intention here is to take this out to InfoDrainage, do the design there, and then bring back the hydraulically designed pipe sizes and gradients and associated manhole sizes. So at this stage I can set this to anything I like, so I'm just going to leave it as it is. Actually, I'm going to set that to a concentric cylindrical structure, and then just go with that. Okay, and then start to digitize these as we go along, making sure that the snap tool is on. So zoom in, pick the first one, snap, pick the second one, and along we go. Okay, and then just escape to finish. Okay, so I've got my pipes and manholes now created within Civil 3D. Next thing I'm going to do is to create my subcatchments. So one of the first things I've got to do, similarly, I wanted to make sure I have my subcatchments in the right place. I could just digitize them here straight within Civil 3D. I thought I'd take some boundaries that had already been created and copy them in and then snap to those. So I'm going to copy them, and a similar process, copy these to a clipboard, and then back into my drawing and paste it in with into the right location, so we can see where those appear now. I'm going to actually create my subcatchments. So from the Analyze tab, there should be a ground data panel. Okay, so we've got the Analyze tab, and then the ground data panel, we see we've got catchments there. So from the drop down, we're going to create a catchment area from object, because I've already got these boundaries digitized. So what I'm being prompted for now is to select one of these polygons. Now you'll see you can see it says select a polyline on the uphill to use as the flow path. I'm going to skip that point, so I'm going to escape on that. Brings me through to this dialog, and in this dialog the main thing that I want to do is to associate the subcatchment with the manhole that it's going to drain to. Now InfoDrainage has some great automatic utilities that do that for you, so you could just export them like this and then allow InfoDrainage to make the connection between the subcatchment and the manhole. But if you want to specify and define which manhole it drains to, you can do it at this point. So all we need to do for that is to click on this box and then pick the manhole that we want to drain to. I think that's it. Is there anything more to it? Again, we can choose we can choose again which labels appear on it, and then under the flow path tab that we've got here, this is how we are going to calculate the time of concentration. The advice here is that, again, we don't have to worry too much, or don't worry at all about it at this stage, because all of those sort of attributes are going to be defined in InfoDrainage. And this is where I talked a lot about this round trip process. There is some catchment attributes which exist within InfoDrainage which don't currently exist within Civil 3D. So when we get into InfoDrainage, you'll see how we have to apply them there. But I think if I'm right, I think we've got everything that we need for now. Yeah, it's draining to the right structure. It's going into the right catchment group. You'll see we've got this runoff coefficient. So I'm going to press OK on that now, and it creates my first subcatchment. Okay, let's do this one more time. Do it for the second catchment. So again, using the drop down, create catchment from object, pick the catchment, press escape because I'm not going to define the flow path from here. I'm just going to tell it that it's going to drain to this manhole. I'm going to define which manhole it drains to, like that. And then I think I've got everything I need. I don't need to put anything in addition around the flow path. Note that we've got this runoff coefficient here of 0.5. I'll talk about that in a second. But let's hit OK now and create our second catchment. Now I'm going to pause the video here. You don't need to watch me. It's just the same process repeated 5 further times to put in these further subcatchments. So I'll pause the video here. Okay, so I've now completed the creation of these 7 catchments, draining to 7 manholes. The only one that doesn't have a catchment associated with it is going to be our outfall. So at this stage, I think it's a good opportunity to save the work. So I'm going to do and save as. Okay, just I'm going to pause it again while I just find the right directory. Okay, so I've just saved it there, and you'll see it's now called initial model. This is the one before it's exported. So the next thing to do is simply to export it to InfoDrainage. Now, as I said, using the 2022 version of Civil 3D and the 2021.7 version of InfoDrainage, and it is a separate installer. So as well as installing the main InfoDrainage package that we looked at the start of this presentation, you also have to separately install the InfoDrainage add-on to Civil 3D. And there are, I believe, 2 main options for buying InfoDrainage. There's the standard and the ultimate versions, and it's only the ultimate that comes with the interaction with Civil 3D. So to get all this functionality that I'm looking at today, you need the ultimate version of InfoDrainage. Okay, but once you have those 2 separate installs, the main InfoDrainage program and this separate ribbon here within Civil 3D, we can then go and export to InfoDrainage. So click on there, select a file location. So today I'm just going to call mine, just on my temp directory, I'm just going to call it test and save it there. Actually, let's give it another name. Let's call it Storm01 test to match the name of the network that we set up. Okay, press next. Now at this time I've got 2 networks, so I just want the first one that I created. Now we get a choice here about whether we want to take the surface out or not. I really don't see any point in doing that. We had that original XML file which we bought into Civil 3D. We're going to take that same XML file into InfoDrainage potentially, so there's no point in taking it into Civil 3D and then exporting it from there. You might as well just work with the original raw data. So let's go next on that. And now we want to set up these mappings. Okay, so we're simply going to do the export to InfoDrainage. Okay, first thing is to select a file name. I'm going to call this Storm01 test on my temp drive. Save that, go through next. I'm going to pick my Storm network, and I get a choice if I want to export the surface or not. I have to say there's really no point in doing this. You saw at the start we imported that XML file. We can take the same XML file straight into InfoDrainage, so there's no point in exporting it from Civil 3D and taking that export through to InfoDrainage. We might as well work with the original data. So I'm not going to export a surface. Press next. I now get through to do my mappings, and as I said when I was creating these pipe sizes, we're really not concerned too much about how these pipe sizes appear in InfoDrainage because they're going to be hydraulically designed there. But just for a starting point, I can give it any old size. So I'm going to say I'm going to start with 100mm diameter for the pipes, and similarly for the manholes, I'm just going to say they're 1.2 meters. But really, like I say, these don't matter because it's all going to be redesigned once we get to InfoDrainage. So just press finish and it should then export, so it goes out. Okay, so let's now see how it appears in InfoDrainage. This is the model we were looking at originally. Let's just open up this. So there's the Stormo1 test that I exported from my temp directory, and that's the model. Okay, so there's a huge amount that we can do within InfoDrainage, but today we're just focusing on one specific aspect, and that's the design of the pipes, the automatic pipe sizing mechanism, which we're then going to bring back those revised pipe sizes back into Civil 3D. So let's set that up. The first thing that we're going to need is some rainfall. This presentation is not really about the selection of rainfall, so I'm just going to create any old rainfall to allow me to do my design. There's whole, if you want to understand about the recommended selections for rainfall, we run a training course where we go into this fully. The rainfall I'm creating today really has no relevance, and it's not our recommendation if you were to do this for a real project. So I'm just going to set up the default events. I'm using a 2-year return period storm for somewhere in the UK, but nowhere really specific. So okay to that. And what else do we need to do? Let's have a quick look at how it currently looks in long section. So to create long sections or profiles, we use these flow paths. So I'm going to start from there, come down to there. Let's have a look at this flow profile now. So we can see we've got all the 100mm pipes, which happen to be the diameter I set up during the export, and you can see that currently they're just placed a consistent distance below the ground. Now we come next to one crucial aspect of this, and this is the definition of the subcatchments. Before we do that, I'm just going to change the labels here. So what I do is on the inflows, go into the display settings. I just want to make the labels a bit smaller. So I'm going to change the text height to 4 and the icon height to 8. That seems to work much better. Yeah, so we're not getting confused by things. Okay, so let's have a look at a catchment, one particular catchment. Now we can see that the volumetric runoff coefficient is set to 0.5 and the impervious percentage is set to 100. Now this goes back to what I was talking about at the start, about you need to make an assessment about how much rainfall that lands on the catchment is actually going to make it into the manholes. And remember that we only get a rainfall contribution from developed catchments, so the roads, the roofs, the hard standing areas. So a typical suburban environment is going to be perhaps 60 or 70% impervious. It's not going to be 100. If you were designing a manhole sitting in the middle of a big runway, or you were doing a huge storage warehouse perhaps, then possibly you get up to 100% imperviousness, but in a typical urban environment it's going to be a lot lower than that. So what we want to do is to change those pervious percentages from 100 down to a more typical value, and let's use 60. Now if you wanted to do a detailed assessment of that, you would use those background maps that I showed right at the start. You would actually calculate the areas of the roads and roofs, and you would work out the individual percentage for each subcatchment. But today we're just going to be taking a blanket assumption of 60% impervious for every single subcatchment. So quite a gross assumption there. We're also going to assume that the time of concentration is set to about 5 minutes, and the volumetric runoff coefficient is going to be 0.75. Now again, there's a huge amount of debate about what that value should be, and today I'm not going to go into that debate, but these values that we got presented here are more typical of urban environments. The main headline that I want you to take away from this is don't just take the values that Civil 3D gives you at this stage. You must edit them within InfoDrainage to get some more realistic values. And like I say, one day maybe, possibly, all of this information will be available in Civil 3D, but it's not at the moment. So this is the main bit where you have to do some edits within InfoDrainage. Okay. Now perhaps an easier way of doing that, because we've got several of these catchments to edit, is using the tables which exist within InfoDrainage. So if you go into the build and then tables, we can see that, and then go into the inflows there. We can customize what appears in these tables. So I need the preliminary percentage runoff and the, where are we, percentage impervious, and we also need the where is it, volumetric runoff coefficients here. Okay, I think that's everything that we need for now. Actually, let's also add preliminary volumetric runoff coefficient. Okay, that looks good. So I'm going to set all the percentage impervious to this typical value of 60, although as I say, you need to make an assessment about what that would be for your catchment. You'll see that it changes this one. It also changes this preliminary percentage. And again, to understand how these two are linked, you really need to come on a training course. We spend several, probably half an hour going through this point. Similarly with this, we want to set all these volumetric runoff coefficients to about 0.75. And you can see all the areas have been calculated for us. Okay. So I've set up my rainfall, I've set up my catchment parameters, those are the ones that I had to edit within InfoDrainage. Next I want to kind of bring those two aspects together. So under analysis, I want to define that I'm going to use all of these storms to do my design. And this presentation isn't really about the pipe design process within InfoDrainage. Again, to understand that in detail, come on a training course. But very briefly, we go into this preliminary sizing, set up our network design criteria, choose the storms that we want to use for this design, and the design options in terms of minimum and maximum gradients, minimum and maximum velocities that we're aiming for, whether we're going to allow backdrops in steep catchments, all of that kind of stuff, which manholes we're going to pick and which pipes we're going to pick from these libraries, and press OK to that. And then hopefully it is a case of then just stepping through this design wizard, which I'll do very briefly. So the first thing it's asking me is which pipes do you want to design. In this case it's all of them because it's a very simple network. And then it goes through and says which rainfall, what's the design criteria, and then it goes away and does it, and press finish on that. And it gives me an understanding of the capacity and the flows in the pipes. But like I say, that's not the focus of this presentation, to understand that process. But what is useful is to then look at the flow profile, sorry, the pipe profile, and you can see how it's changed. We've got a different gradient than we had before. They're not just a consistent depth below the ground. They have now been hydraulically designed, and you can see that they're different sizes. And if we want to look at those in more detail, we can go back to the tables that I was talking about earlier, or I mentioned earlier. So we looked at the tables when it came to the inflows. Now we want to look at it for the pipes. So just go back into the table a second. So when we come to look at the pipes, we can see that we've now got a slope designed, we've got invert levels designed properly, and crucially we've got the pipe sizes. So you can see there's now several 150s and some 225s in there. Okay, so I've done my design. Now I'm going to save my network in InfoDrainage. And the next thing is to go back to Civil 3D to re-import this network. So back in Civil 3D, now at the moment we've got the original network in here, and if I was to import again from InfoDrainage, it would delete this, sorry, it would duplicate this network. So I need to delete this original network. So firstly, delete the catchments. So just delete the catchment group. Take that out, and then secondly delete the pipe network. Okay, so I've got back just to the original line to show me where the pipe network is, and then bring back in from InfoDrainage. So here we go, import from InfoDrainage, pick the file, this Stormo1 test that I've been working on, click next. Now at this stage we get the option to bring in a number of different phases. This could be different design options which InfoDrainage allows. This model that I'm currently working on just has the one phase, so it's obvious. And I could bring in the Civil 3D surface again, create a new surface from InfoDrainage, but I'm just going to stick with that original XML file that's been used throughout. Click Next. Now at this stage I am trying to essentially marry up what I have within InfoDrainage to what I need within Civil 3D, and this is where these parts mapping comes in, the parts list that I set up earlier. So if it hasn't already been automatically associated, you just go through, pick the part family, and then pick the relevant size from here. So for us it's very easy, there's just the two new pipe sizes which were designed, so there's just two mappings that needs to be created. Do the same with the manholes, so again pick the part family and pick the 1.2 meter diameter that we set up earlier. So at this stage, bring it back in. It obviously is important to do that mapping. On the way out it's not important because we're going to then do all the hydraulic design within InfoDrainage. Now once you've done this once you've set up these mappings once, you can then save it. So this is saved as a InfoDrainage specific file, and then if you ever, if you're going backwards and forwards between the two packages, each time you come back in, you can just load the file in again, and it remembers your remembers your mappings, and then you can make any additional ones to reflect the new pipe sizes that you may be dealing with. So yeah, so you've got a save there and a load there to do that. Once that's done, press finish. Should bring it all in, and that's my revised network. So I guess the final thing I want to do just briefly is to just kind of prove that this is actually a revised network that we've brought in. So I'm going to create an alignment. So from the Prospector tab, I'm going to select the network. Then that brings up this tab here, and I can create an alignment from the network. So just hit OK. It's asking me to pick the first manhole and the last manhole in the series, and then asking me for, I believe, some details of exactly how it's going to appear in terms of labels. Go with the defaults, and then I've got to load in the relevant surface, draw the profile view from that, and then again some just additional details about how it's going to create the profile, and then I'll finally just need to place it where I need. And we can see here that we've got the two pipe sizes that we designed, the 150 and the 225, and we've got the revised invert levels that are obviously coming in. It's not the consistent cover level that we had before. So that's it. That's how we do the round trip, starting in Civil 3D, going out to InfoDrainage, and then coming back to Civil 3D with our revised design.